All right, hello everyone. I'm going to be going over notes here on my recorder today since I will be gone for a track meet. We are going to be starting the second half of Chapter 7, so that's the Chapter 7 Part 2 here. And this whole unit is going to be on factoring. And I've broken things down a little bit differently than what the book had, so I'm not going to have exact section numbers for each part. So I'm just going to put a heading at the top here for whatever we're doing that day, and we'll keep it organized like that. But the rest of this chapter, even though it's still Chapter 7, it's all going to be on factoring, and I'll treat it like its own chapter. So we're basically starting it here today, and we'll have a separate test just on factoring. Okay, so it'll kind of be like its own little chapter here. Okay, so what we're going to be talking about today, we're going to go over some of the vocab of what some of these things are, and we're going to be talking about factors and the GCF. Okay. So first thing we need to talk about, what is a factor? And some of this you guys will have done in middle school with regular numbers, and we're going to just build on that, add a little bit to it, because we're not just going to be using numbers, we're also going to be using algebraic expressions. But it is going to be kind of built off of stuff that you guys are already familiar with and have already done. Okay, so the first thing we need to talk about is factors. Okay, so the first thing here, factors. A factor is a number or expression. So this is what you guys have done before. We're going to be adding in expressions that divides another number or expression evenly. Okay, keyword there, evenly. And factors are usually smaller pieces. So for example, 2 and 6 are both factors of 12. Okay. 2 and 6 will both divide 12 evenly. Also, I can do that with algebraic expressions. So for example, 2x is a factor of something like 8x. Okay, 2x will divide 8x evenly. If I take 8x and divide it by 2x, it'll come out evenly. Okay. Another way of thinking about factors, and I think this is really helpful sometimes, is if this is a factor, then that means I can multiply this by something to get 8x, right? I can take 2x times 4 and get 8x. Just like if 2 is a factor of 12, I can take it times 6 and get 12. All right. I do want to do one with exponents here because this does tend to be an area that we struggle with sometimes. So I'm going to do something like 3y to the third. Okay. So I want to look at 3y to the third, and it is actually a factor of 6y to the fourth. Okay. Now, a lot of people will get thrown off because, well, they're like, well, 3 is not a factor of 4. Well, the exponents don't have to be factors of each other. 3 is a factor of 6, right? And actually, any smaller exponent will work because I can multiply this by a variable to get y to the fourth. If I take this 3y to the third times 2y, I will get this. Okay? So the exponents, you're not multiplying the exponents. You're adding them. Okay, the next thing we need to talk about is the GCF. Okay? And I'm fine with using the abbreviation GCF as long as we know what it stands for, and that is the greatest common factor. Okay? So what is the greatest factor that two things have in common? And this is what you're actually going to be doing on your assignment today. You are going to be finding the greatest common factor of two expressions. So your directions are to find the greatest common factor. Okay, so for number 1, we're going to have 6x squared and 9x. Okay. And if I want to find the greatest common factor between these two things, I kind of break it into a couple parts. I first look at just the numbers, 6 and 9. And their greatest common factor is 3. But then I also have to look at what variables they have in common and what is the greatest common factor. Well, this one has x squared, and this one just has an x. So the greatest, not the greatest one, but the greatest thing that they have in common is just a single x, right? They don't have an x squared in common, just an x. Okay. And if we go up in exponents a little bit, okay, 4x to the third and 12x to the fifth. I'll look at the 4 and the 12, and well, they have a GCF of 4. And then for the variables, they actually will have a x to the third in common. Okay. And if you think about it, I can multiply this times something to get both of these. Okay, I can multiply it by 3x squared to get 12x to the fifth. All right, number 3. So now I'm going to add in more than one variable. And it doesn't really change anything. I just go with the number first, so I'll look at the 16 and 20, and then I look at the x's, and then I'll look at the y's. Okay? So 16 and 20, well, those have a GCF of 4. So I look at all the factors of 16, all the factors of 20, and what is the greatest one that they have in common. It should be 4. These only have one x in common and one y in common. Okay, we'll do one more here. Okay, there's a couple things that you need to be careful of on this one. First is just making sure that I get the absolutely greatest common factor between 18 and 36, and not just a common factor. These two numbers actually have a lot of things in common. They're both even, so they both have a factor of 2. 3 goes into both of them. So does 9. But the greatest factor that they have in common is actually 18. Okay? 18 goes into itself and 36. Okay? Then I look at the variables. This has x to the third, but this one only has an x. So they only have one x in common, and then they both have a y. I said that was going to be the last one, but I do want to show you guys one more. Because I wanted to show you one where the numbers were maybe a little bit different. So if I look at 12 and 17, they actually don't have any common factors other than 1. Okay? And you can put a 1 there, that's fine. Then when I look at the variables, they have an x in common and they have a y in common. And I want you to get rid of that 1 for your final answer, so your final answer should just be x, y. We typically don't worry about that 1 if it's being multiplied by anything. Okay, and that is it. Just remember that they always do have a common factor of 1 if there isn't anything else. You will see that sometimes. So that should be it. If you have any questions, feel free to ask Mrs. N. She'll be able to help you. All right.